A very good afternoon, everyone, and I hope that all of you are doing well. And I also hope that you're keeping yourself safe and sound. Okay, so welcome to week 10 of the semester. So in this week, we have the following things that needs to be done. First of all, we'll be looking at our lecture notes for week 10. Moreover, there's a set of tutorial questions that need to be answered and submitted in the tutorial forum provided. And this tutorial will later onwards be discussed in our tutorial/lab class. Moreover, the tutorial/lab class will also have some use case based exercises this week, so we'll be looking at them very particularly. Moreover, I would also ask you to go over the lab exercises which are already on the week 9 section of the Moodle shell, week 10 section of the Moodle shell. I've got 3 exercises for you. Okay, so please do go over them, and also please start working on your major project. It contributes 10% towards your coursework. Okay, now you have a short test as well. Initially it was scheduled for week 10, but I will shift it somewhere around week 12. Okay, so that you get ample time to revise. And this would be multiple choice questions. Most likely I will incorporate some true or false question in it as well. More on this will be disseminated to you in weeks to come. But so far, I'm thinking of hosting it somewhere around week 12 to week 13 of this semester. Now, also, please do note that your major project, the due date, it is on the 31st of October, and the time is 11:59 p.m. Please ensure that you get your submissions done before the 31st of October. Apart from that, okay, now your coursework so far, you should be able to see the entire of your coursework in your Moodle gradebook. Please do have a look at it. If you have any questions or queries, then update me accordingly. Okay, now is there any questions or any queries from anyone before we move on to week 10? Any questions or any queries from anyone?
No, sir.
Okay, no, okay, if no questions or queries, let's begin off with our lecture notes. So today's lecture notes is about user interface design. Now, this is the phase of user interface design that generally takes place when you are developing the information system. Now, before you develop it, you need to go around and design it, and the designing portion also plays a key role. Now, this user interface design, okay, like I mentioned, it takes place in the developing stage. Okay, it's planned, it's analyzed, and it's designed in the previous stages accordingly. All right, so it's a continuous planning from what you have been doing from preliminary investigation, analysis, design, and implementation. So in today's lecture notes, we will be looking at what are some of the things that we will be that needs to be done when you are looking at user interface design, and also what are some of the techniques that you can occupy when you are designing a user interface. So the chapter objectives is explain the concept of user interface design in human-computer interaction, including basic principles for user-centered design. So we'll look at what user interface design is, and we'll also see how human-computer interaction plays a key role in UI design, okay, and some basic principles. Moreover, we'll explain how experienced interface designers perform their tasks. We will describe some rules for successfully designing an interface. And finally, we'll discuss input and output technology issues related with user interface design. Moreover, we'll look at effective source documents and forms. We'll explain printed output guidelines, describe output and input controls and security, and finally explain modular design and prototyping. Now, some of the things that we will be going over into today's slides, they would be like supplementary stuffs. You don't basically need to know each and every bit of detail. So wherever I will be telling you that something is important, please do list and note it down. Okay, system design phase overview. Now, goal of system design is to build a system that is effective. You have to build a system.
So we are not able to see the notes.
You're not able to see the notes.
Okay, sir. Yes, sir. Yes, sir.
Sorry for that. Okay. Now, goal of system design is to build a system that is effective, reliable, and maintainable. Now, this is the ultimate motive of any system designer or any project manager or of any system analysis is when you are designing a system, it should be effective. That means it should actually work. It should be reliable. That means it can work 24/7. And also it should be maintainable. When we say maintainable, if you want to run any upgrades, if you want to get something patched up, okay, it should allow you to do so. So our system is effective if it supports business requirements and meets user needs. Reliable if it handles input errors, processing errors, hardware failures, or human mistakes. Maintainable if it is flexible, scalable, and easily modified. So again, when you're looking at when a system is effective, you're looking at whether it is able to meet the needs and the wants of a specific user. Most probably you're concentrating on the needs. When we say if it's reliable, that means it should be able to handle input errors. It should be able to process errors. It should be able to handle hardware failures or human mistakes. Now, how does it handle hardware failures or human mistakes? Probably it can alert you, okay? Or probably it can give you some form of a message or so forth. And maintainable, it is flexible in terms of it is able to do certain things beyond the needs section. So that's where needs and wants come in as well. So need, when we say it meets user need, that means specific needs. That is what the user needs. Okay, what that is all the compulsory thing that a user may want from a system. But apart from when we say it's flexible, we're looking at some of the wants of the user as well. Scalable, that means it is able to accommodate more requests or services, and then easily modified. Comes back to the word maintaining it. Now, will it succeed? Suggestions for successful design. One, you have to think like a user. So carefully examine any point where users provide input or receive output. Anticipate future needs and provide flexibility. Anticipate possible expansion, offer several alternatives, manage data effectively. System should enter and verify data as soon as possible. Input data must be close to its source. A secure system must include audit trails. So first of all, think like a user. So a system should be designed in such a way that it may think like a user. In other words, the way that a user thinks, the way that a user would want things to be designed for them or do things for them, that's what the system needs to do. And it should anticipate future needs and provide flexibility. That's where the word scalability comes in, okay? And manage data effectively. So managing data, taking data, process it, produce output, but all should be done as securely as possible. Now, the very last point over there on manage data effectively says a system must include audit trails. So when you talk about audit trails, generally audit trails is related to accounting terms. Okay, so in accounting terms, it means a detailed chronological record whereby accounts are recorded and so forth. Okay, now in computing terms, our audit trail, we may call it as a log. A log is a track of all the things that a system does. So generally, probably at a regular interval, a system administrator or so forth can do a log check to see if something is suspicious. If something seems suspicious, That's where they know, okay, they need to go and verify and most likely secure the system even better. Okay, users can design their own output. System designers are more aware of user needs and desires. So what happens is users can design their own output. Now over here, what we're talking about is we are bringing in the users as the centered element. When we say centered element, that means whatever you do, you have to take in the consideration of the user. Now, why do we involve users while designing a system user interface? Because these are the people who will eventually go around using the system. If it does not meet their needs and wants, there's no purpose in designing such a system. Centralized IT departments no longer produce reams of printed reports. Customer design output is the current trend. The user interface has evolved. Most user information needs can be met with screen-generated data, continues to evolve with the use of mobile and wearable devices. Now, screen-generated data is just a way of you presenting data in forms of or through the computer screens. Example, through graphs. So the graphs generally are generated itself by a computer system. For example, how we do in Microsoft Excel, we have a table and just a click of a few buttons, we can generate a graph. That's an example of screen-generated data. Now, so what has happened is over the period of time, IT has moved or has evolved. Now, the evolvement has led to not printing out reams of papers of reports, but rather presenting reports in terms of graphs and in terms of soft copies. Now, to do that, so customer views and customer needs and desires again needs to be taken in and designed accordingly. So what is a user interface? It describes how the users interact with the computer system. In other words, if you're using Microsoft Word, when you click on the bold button, when you click on the italics button or underline button, you are using the interface, the user interface. Now, the opposite of user interface is command driven, whereby you actually have to write down codes to go around using a system. In the old days, when computers were not using graphical user interface, so that's where they had to use DOS command to go around performing tasks in a computer. Central to usability, when we say central to usability, it is where the new system designed or the user interface design has to be user-centered. When we say user-centered, is putting the user in the middle of the development stage and asking him or her what their needs and desires are. By the way, you need to note it down what a user interface is. Please do so, or put a mark somewhere. Now, HCI, human-computer interaction. It describes the relationship between computers and people who use them to perform their jobs. Now, human-computer interaction is basically a study of how humans interact with computers. Okay, and one of the most easiest ways in which humans interact with computers is the use of graphical user interface, GUI. Okay, so note this down as well. Human computer interaction is a study of how humans and computers they interact, and the interaction generally occurs with a graphical user interface. And the last point over there, objective, is to create a user-friendly design that is easy to learn and use. So the main focus of HCI is when a user interface is designed, it needs to be designed in such a way that it is a very user-friendly and it allows easy learnability skills and easy usability skills as well. 7 habits of successful interface designers. So when interface designers, when they are designing the graphical user interface, by the way, these interface designers or graphical user interface designers They are intelligent people. Why? Because they are skilled with computer programming languages, so that they go around designing the graphical user interface. For example, if you see a website which is very stunningly designed, so you know that the graphic designer is an intelligent or well-learned person. Same thing here. Okay, so first of all, the very first thing the interface designer needs to do is understand the business. So when we talk about understanding business, is whereby the interface designer must understand and must know all the business functions that a organization performs. He or she should also know, okay, what form of system support an individual, department, and the entire enterprise needs as a system goal. Okay, so the interface designer needs to understand these concepts. Moreover, the interface designer needs to maximize graphical effectiveness. When we talk about graphical effectiveness, brother, what we are talking about is generally using as much as a graphic as possible, but in a very appropriate manner, not overusing it, not underusing it, but using it effectively, okay, so that the system becomes more and more interactive. For example, instead of asking the user to click on 3 or 4 separate links to go to a specific location, you can just get a button designed up, and with a click of a button, it allows the user to directly go and land on that particular page. So that's an effective use of graphical interface. So what is a graphical interface there? That's the button. Okay, now another successful habit of a interface designer is to think like a user. Now, this is where the interface designers needs to put their egos behind and start enacting and thinking like a user. Why? Because generally users are those people who will go around using the system. So if the designer feels that, okay, this is what I want, this is what I should do, and this is what I prefer, so that's a no-no. Okay, that's a bad habit. A good habit is the designer needs to think about how a user would go around doing it. The only way he or she would be able to know how a user thinks is actually to go and sit with the user, observe things, ask them questions, okay, and then ask them to ask the suggestions. And that's the way in which you can get a very good interface design. Okay, the other thing that you have that a interface designer may do is use models and prototypes. So user models and prototypes are just like a dummy version of the actual system, but with the prototype in the model, the user is able to test and have a good feel of how the interface would be like. So if they would use it before the actual thing is designed, they would be able to give good and effective feedback. Now they can even give after using the actual system, they can give feedback, but what's the use? The designer will end up consuming a lot of time, and also that it will be very troublesome in just in case the system is not too maintainable. Okay, so you the user models and prototype, okay, the designer would be able to get the users to test the system and provide with some sort of feedback. Now there's another word given there is use of storyboard. Storyboard is just like you having a pictorial view of the entire system. Now storyboards, the best way I could think of storyboards is this. Remember in I don't know if they still have in local newspapers or not, probably somewhere at the back of the newspaper in the sports section or before the sports section or in the entertainment section, we used to have cartoons. Remember we used to have graphical cartoons? Now, those are some of the examples of storyboard. So you have something done in a graphical aspect. Now, generally, when you have a superhero movie and all those stuffs, so they actually get a storyboard done, something like a comic kind of thing done, comic book kind of thing done, and based on it, then they would go around and creating the actual movie. So likewise here, that's why it says use of models and prototypes, and storyboard could be one of it. Focus on usability. Now, when we start focusing on usability is we then start concentrating on how easy it is for a person to interact with the system. The term usability means the ease of use. Okay, so focus on usability. Invite feedback. Now, I would say this is one of the best things you could do when you are creating a website, when you are creating a new system, or even when you are doing a lot of things in your life. You can always get feedback. Now, in terms of a good habit of a interface designer, the feedback can be done through the use of the actual users. Probably a designer may get a feedback from another designer. Okay, or probably you can have a group of team members who would sit back and scrutinize a design. Scrutinize means see the good and the bad points. Okay, but actually try to get as much as in the different varying levels of users to come and scrutinize the entire design. Why different levels? So you have people who are working at an operational level, ground level, you have people at managerial level, you have people at executive level. Now all three of these people have the different point of using the system. So in that case, having all having all three on board and getting feedback from them would be the perfect thing. Now document everything. Okay, now this is also very simple. Okay, so why document everything? So that it could be later used by other programmers, or just in case if the actual interface designer, let's say he leaves in the middle of the project, the next person continues. Now it's this, sometimes it's a very common habit. You'll see people who would not want to share their knowledge, would not like want to share their work. Do not be like that. Okay, try to share your knowledge as much as possible. Try to teach people to develop their skills and grow. Why? Because overall, when a lot of people come around with skills, okay, people come up with new ideas. With new ideas we have new businesses. With new businesses our economy picks up. With the picking up the economy our country grows. Finally, when the country grows, we all grow together with it. Why? Look at countries like Australia, US, UK. Okay, these are fast growing countries. People earn more. Why they earn more? Because the country is grown, the country is that big. Okay, it can actually allow businesses to work or to function at an extent where they actually pay their staffs a huge amount and they earn a huge amount as well. So please share the knowledge. All right. Okay, guidelines for user interface design. First of all, create an interface that is easy to learn and use. Okay, now why we should create an interface that is easy to learn and use? So that it is effective. Okay, one, it is effective in terms of using it. Moreover, people are able to be very productive with it. It's not that you create an interface, it becomes so difficult to learn and so difficult to use that half the time people end up messing up things rather than getting things online, or rather than getting things or job done well. So what are some of the things you can do when you create an interface? Focus on the system design objectives. Create a design that is easy to understand and remember. Provide commands, actions, and system responses that are consistent and predictable. Allow users to correct errors easily. Clearly label all controls, buttons, and icons. So these are some of the things that you need to ensure when you're creating an interface. I will not go much depth on it. Probably I will just explain the topic and the bullet points. Probably I'll just read them out. And if I feel something is important, I'll explain it to you. There's more to it. Select familiar images that the users can understand. Provide on-screen instructions that are logical, concise, and clear. Use all commands in a list of menu items. Dim any commands that are not available to the user. Make it easy to navigate or return to any level in the menu interface. Now, I will definitely would like to explain the first one, select familiar images. Select familiar images is just like you using the very same icons that you provide in other systems. For example, whenever we see a X sign in a red box right somewhere on the top right hand of the screen, you know that represents close. Whenever you see a document icon with W written on it, you know that that's Microsoft Word document. Or whenever you see something in green and has a worksheet kind of icon, you know that Microsoft Excel. So use of familiar images. Do not represent a, do not come up with an image or icon that people hardly know, and you do not have a label for it. So people may not able to know it, or they will hardly use it because they don't know what it is. So you need to ensure not only you provide them with the images, but you provide a good set of labeling as well. Another thing mentioned there is show all commands and a list of menus. Having things in a menu basically eases up the navigating skills, or eases up the navigation. So navigation is you moving back and forth in the system. For example, look at a website. So you have a home page, about us, contact us, services, products, and so forth. So when you read that, you are able to know, okay, if I click on this, this is where I land. Okay, so those are called navigation menus. Okay, enhance user productivity. So another guideline is you should get all these features up on board on the system that allows the user to be more productive. So productivity, the definition of productivity is the level of output given the level of input. In other words, how much effort you put in to get a certain amount of output. So your level of input should always be equivalent to the level of output. That means you put in 1 hour of work, you should get result that is worth 1 hour of work. Okay, so if you design a system in which you put 3 or 4 hours of work but produces you with the result of 30 minutes only, what's the use? Okay, so ensure that you are creating an interface that enhances user productivity. So how can you do that? So we have some points written in. Organize tasks, commands, and functions in groups that resemble actual business operations. Create alphabetical menu lists or place the selections used frequently at the top of the menu lists. Provide shortcuts for experienced users. Yes, you can do that. Provide shortcuts for those who are experienced users. The opposite of experienced users would be novice users. Those are very new. They wouldn't prefer to use shortcuts. Okay, but where possible, have shortcuts for the experienced users. Use default values if the majority of the values in the field are the same. Use a duplicate value function to allow users to turn this feature on and off as they prefer. Okay, and then provide a fast find feature, probably to the use of a search box. If available, consider a natural language feature that allows users to type commands or requests in a normal text phrase. I feel we are living in a state whereby we should always use natural language. Natural language is a language that we generally speak, for example, English. So rather than using a technological terminology, okay, or a technical jargon, you can go and use natural language. Okay, so that will make the work of a user very, very easy. Remember this. If you use an IT term, a technical IT term, in a system, you have users who may be accountants, you have people who may be non-IT experts. Okay, they are just basic users of computers. Now you have people, believe me, in many organizations, you have people who are just basic computer users, but they hold large positions. Why? Because using the computers or knowing the technical computing terms is not that compulsory work tasks for them. Okay, so for them, they would need natural language. Okay, natural language, the common language that we speak. So that needs to be put into the interface. Provide users with help and feedback. Now, help and feedback, they are two different things. Help is whereby the user is stuck somewhere, so he or she is able to refer to few elements within that system interface and is able to move on in doing his or her work. Now, help features, there are several ways. You can have a search box for help. You can have frequently asked questions, FAQs. You normally have that in a website, or sometimes you can just have instructions. For instance, you have a date, let's say a date title, and then you're given a box to enter the date. Now you are thinking whether I enter date in terms of day, months, year, months, day and year, or year, month, day. Now that's confusing. So instead of having 3 or 4 different types of formats by different users, you can put a comment that your date needs to be in this specific order, or an instruction. So that's help. Feedback is whereby when a user does something, he or she is given a feedback, or he or she is given a idea from the system that this might be right or this might be wrong. For instance, how many times have you noticed this when you are filling in an online form, when you enter something correctly, you meet all the requirements, it represents you with a tick. Sometimes if you're not able to meet the requirements, it goes red and then tells you that something is wrong, and it gives all the possible things that you may have done wrong. So that's feedback. Now, how do a system how does a user interface designer provide help and feedback? Ensure that help is available on demand. Provide user selected help and context sensitive help. Now, context sensitive help is, let's say you are filling in a form and you are not able to enter your date of birth correctly, or something goes wrong. So as soon as the system picks up that this is a place where you have gone wrong, it gives you a list of subtopics to click and view how to go around correctly entering the date of birth. Provide a direct route for users to return to the point from where the help was requested. Include contact information. The easiest way is you can go and contact through the email, phone number, or sometimes you have chat boxes. Require user confirmation before data deletion. Okay, now you must have seen this sometimes when we go around deleting something, it asks you, are you sure you want to delete this? So that's feedback. Provide an undo key. Okay, that means you do something and go a step backward. Undo. When a user-centered command contains an error, highlight the erroneous part. We just talked about it. When something goes wrong, it goes red in color. Erroneous part. Use hypertext links to assist users. Display messages at a logical place on the screen. Alert user to lengthy processing times or delays. Allow messages to remain on the screen long enough for users to read them. Let the user know whether the task or operation was successful or not. So these are some of the things in which you can allow the user with help and feedback. Okay, so this is an example given for a menu system. Okay, now what you'll notice is that you have a main menu. So in the main menu, you have three different topics. You have customers, orders, and products. So what happens is you can click in either of them at any point in time so that you end up on that particular screen. So this provides you with a very easy navigation system. We're still on providing users with help and feedback. Provide a text explanation for an icon or image on a control button. Like I mentioned earlier, you have an image or an icon, probably an explanation or probably a label would do. Use messages that are specific, understandable, and professional. Create an attractive layout and design. Now, as much as you'd want to make things simple, sometimes having an attractive layout and design basically is very effective. How? If it's just a plain boring white and black screen, okay, the user gets bored over time. If the user sees that there is bright colors, there's images, and also it has some flashy images or some unique features in the layout, they get this. There you are able to seek a lot of attention for them, and it looks very, very attractive. So how do you do that? Use appropriate colors to highlight different areas on the screen. Use special effects sparingly. Sparingly isn't, do not use it excessively. Okay, if you use it too much, again, that becomes too daunting for the user. Moreover, it takes in a lot of time or wastes time. Use hyperlinks that allow users to navigate to related topics. Like I mentioned, if you would go back a slide here, so these may be an example of hyperlinks. Group related objects and information. Now, group related objects and information. So you have a form, it asks about your personal details. So all of it is grouped together. If you, and then it asks you about your work experience, that again is grouped together. It asks you about, let's say, your qualification or education, again, that's grouped together. So that's what it means. Display titles, messages, and instructions in a consistent manner. Ensure that commands and similar house actions will have the same effect. Require the user to confirm the entry by pressing enter or tab. Remember that users are accustomed to a pattern, for example, red to stop, yellow to caution, and green to go. Provide a keystroke alternative for each menu command. Avoid complex terms and technical jargons. Okay, now consistency is again mentioned here. So when you are designing a system, you have to be consistent, and also you need to ensure that if you have other systems, let's say you have a lot of different types of systems, a lot of different types of softwares, if people are accustomed to using them in such specific way, so that such specific way should also be incorporated in your design as well. Makes it easy. Okay. Now, enhance the interface. Opening screen is important as it introduces the application. The starting point can be a switchboard with well-placed command buttons for navigation. Use a command button to initiate an action. Try to create customized menu bars and toolbars. Add the shortcut feature and that lets a user select a menu command. If variable input data is needed, provide a dialog box that explains what is required. So it's all about you trying your best, or the user interface designer trying his or her best to enhance the interface. Now, how do you enhance the interface? You can have fancy menus, okay? You can have buttons, you can have menu bars, and you can have dialog boxes. A toggle button, what is a toggle button? A button that allows you to switch on and off, okay, something like that. Use a list box that displays the available choices. Use an option button or a radio button to control user choices. I think you're aware of radio buttons, just circles, 2 circles, so you can click, and the one which is selected will have some form of color effect added to it. So those are radio or option buttons. You can use checkboxes as well. Checkboxes is used to tick something. Sometimes you have an X instead of a tick, and then you also can use calendar control to enter dates. Now, calendar control is more effective than you actually going around manually entering the dates. Sometimes when you have calendar control and you go around manually entering the dates, so it takes you to that specific calendar. Okay, so with that, what happens is that there is no different types of formats that is thrown into the system. It's just one specific format. Focus on data entry screens. Okay, now why there's a lot of focus on data entry screens is because you want to ensure that the users are able to feed in or enter data as easily as possible. Now, when it comes to users for entering the data, try to keep it in a very structured manner. Why structured manner? So that it becomes easy for you to make reports later onwards. Structured manner would be like you are giving them choices, drop down box, probably a radio button, an option button, okay? You'll have a set of menus, okay? You have a button and so forth. If you have unstructured manner, so user will go around writing down whatever they want. So in that case, there's a likely chance when you're going around making reports, a 1 hour report that occupies time for a structured report may be pushed forward to a couple of hours for you to present a unstructured report, for you to produce a report on unstructured entry of data. Okay, so try your best to have a simple layout, and the best way in which you can do it is by using a form. Okay, provide a way to leave the data entry screen at any time without entering the current record. Provide a description caption for every field. Description section is just like a bringing up a label or instruction. Provide a means for users to move among fields on the form in a standard order or in any order they choose. Allow users to add, change, delete, and view records. Design the screen form layout to match the layout of the source document. What is a source document? For example, this is very tricky now. When you are, let's say you're working for a supermarket kind of organization. So a source document would be, let's say you've received a receipt from a supplier, and that receipt has set of columns, okay, and total amount at the bottom. So Likewise, when you are entering that data of whatever things you have bought from the supplier, it should be very much similar to your source document so that it becomes easy for the person who's entering data to go and enter the data in a much more effective and productive manner as possible. If it differs, there's likely chance he or she may end up making errors. Okay. Another thing is to do is have a standard layout. Okay, standard form layout for a system. Now, where do you get the standard layout? Generally, when you create a software or a system, you can always go and search up on the web for a standard layout from a project management company, or probably just browsing over the net. Display a simple format like month, day, year, and use an input mask. Input mask for a date would be a date control. Require an ending stroke for every field. Ending stroke is just like those which are basically are compulsory fields that you need to enter. Do not require users to type leading zeros for numeric fields or trailing zeros for decimals. Display default values. Provide users with an opportunity to confirm the accuracy of input data before displaying it. Okay, now last portion is just like you are entering a form, you enter something incorrectly, it gives you an error telling that you have entered something incorrectly. So that's what it means. Use default value when a field value will be constant for successive fields or throughout the data entry sessions. Okay, now use validation rules. Now validation rules are a set of rules which goes around checking your entry. Okay, for example, I'll tell you is data type checking. So data type checking is where you are supposed to type something in numbers, you type something in terms of alphabets. So that's incorrect. Sometimes you have a set of range. Let's say you want the age to be entered from 15 to 65, but you enter the range, let's say 80. So that goes out of the range. There are also validation rules for compulsory fields and so forth. Let's go and read them out. So validation rules, you should know them. So please list it down somewhere. So there are few, there's about 8 or 9 different types of validation rules with interface. First one is sequence check, used when the data must be in some predetermined sequence. Okay, so that means you have to enter data in a sequence form. That means you have a set of fields, so all the fields need to be filled in. So you cannot jump into the second field unless and until you have entered in the first field. You cannot go around for example, filling in your education details unless and until first of all you've given your name, your date of birth, and so forth. So that's sequence check. It checks whether the data has been entered in a sequence or not. Existence check applies to all mandatory data items. Asterisk, remember red asterisk? Data type check tests to ensure that a data item fits the data type required. The example that I gave. If it's numeric, you have to enter numeric data. If it's alphabet, so you have to enter alphabets only. Range check used to verify that the data items fall between a specified minimum and maximum value. Example that I gave earlier, 15 to 65. Sometimes, I normally find this minimum and maximum value is when you go onto this bank websites and try to check your loan eligibility. So you have a minimum and a maximum value. Okay, so the minimum value of loan that you may take, home loan, is let's say about $50,000. So $50,000 going on minimum, maximum is let's say 1 million. So you can write down 1.5 million. Okay, so 1 million only is a maximum. So that's what the range check does. The next type of rule that you have is a reasonableness check. Reasonableness check, okay, identifies values that are questionable but not necessarily wrong. So reasonableness check, what it does, it basically, if it sees that something may be questionable, it allows you to go and confirm it. Once you confirm, you can proceed. Okay, validity check used for data items that must have certain values. You cannot leave something as blank. Okay, validity check. Combination check performed on two or more fields to ensure that they are consistent or reasonable when considered together. Now, combination check is something like this. Let's say you enter your date of birth, and according to your date of birth, you are 23 years old. And you say that the number of years of experience that you have is 10 years. Now, when a combination check is done, so the system will check, hey, this guy is 23 years old. He or she has studied 3 or 4 years in university. How is that possible that he or she has 10 years of work experience? Now, it is possible. I'm not saying it's not possible. It is possible, but the combination check will go and see and get it validated from the user. And then batch controls, totals used to verify batch input. Batch input is when you're trying to enter data into the system in bulk, not regularly, okay? Batch processing. Reduce input volume, okay? Reduce input volume is try your best to ensure that you have little input from the user. When we say little input from the user, not in terms of typing, but them in terms of selecting and manipulating things. Input necessary data only. Do not input data that the user can retrieve from system files or calculate from other data. Do not input constant data. Use codes as they are shorter than the data they represent. Okay, source document. So that finishes up on guidelines for user interface. Now, I would suggest for you to actually know a few guidelines from here. You never know. Questions like this might pop up in your exam. Okay. Especially try your best to learn about the different types of validation rules. These are very common kind of questions in multiple choice. Okay, source documents and form design. GIGO, garbage in and garbage out. Quality of input depends on the quality, quality of output depends on the quality of input. That means if your input data is of quality, your output is also word of quality. It's just like if I put it on the other way around, is when let's say you're planting a tree, okay, or let's say you're planting something. So you put in a very poor quality soil in one of the plant, and you put in a quality of soil in the other plant. So which one will grow better? Plant A, which is of poor quality, plant B, which is of better quality. Obviously plant B, okay? So your output, that means the plant would be better. It will grow better, it will bear better fruits. Likewise, same thing with system. When you put in or when you do your input of data or information, you need to ensure it's of quality. If input is of quality, your output will absolutely be of supreme quality as well. Source documents are all those documents that collects input data, triggers an input action, and provides a record of original transactions. A source document is any document that has a record of transactions. A good form layout makes the form easy to complete and provides enough space. Information should flow on a form from left to right and top to bottom. In other words, when you have a form which has a good layout, what happens is basically you are using the space in that form very, very properly. You're not wasting space. Okay. Overview of report design. Organizations strive to reduce the flow of paper and printed reports. Why? When you have a lot of printed reports, you're wasting resources. Okay, now wasting resources is one. Okay, it takes time to get things printed and done. Two, thirdly, where do you dispose it after a period of time? This additional cost to an organization. So that's why many of the organizations, they're trying to eliminate the use of papers. Again, also when you are using a lot of papers, you're wasting trees. Okay, papers, they are made out of trees, so you are just throwing away trees. Okay, now users find it handy to view screen output, then print the information they need. Printed output is used in turnaround documents, in sales documents. Reports must be easy to read and well organized. Okay, and then you can use some form of softwares to get the reports done, especially in terms of Microsoft Access. You can even use Excel for graph generation. Types of report are important. Please note it down somewhere. There are a few reports. First of all, you have detailed report. Okay, it produces one or more lines of output for each record processed. Okay, it's more like it's a lengthy report. Exception report, it displays only those records that meet specific conditions. So exception report is just something like this. Let's say your supervisor at work tells you, hey, I need a document which says how many people were absent last week. So the condition, how many personnel were absent last week. So you make a report of it. Now, when a report has some specific kind of condition, it's called an exception report. Summary report, okay, basically it provides a summary of certain events for a period of time. User involvement. Users must approve all report designs in advance. A mock-up or prototype can be prepared for the user to review. Okay, report design principles, you need to have a header, you need to have a footer. Microsoft Access, okay, I think you've done this in CIN603. So what all things you should include in a report? A header, a footer, okay, avoid repeating fields, okay, consistent design, okay, try to have the design in all the forms consistently. Repeating fields, okay, try to avoid them, but it sometimes when you have repeated fields, it also helps in providing clarity. Now repeated field does not mean is you ask name once and then you ask the name again, you ask date of birth once, you ask date of birth again. No, not that. Repeated fields would be something like this. So it's more likely is your place, your residence. So you would say probably you will stay in, let's pick an area, Natambua, okay, region, so western region, Alotoka western region, something like that. Okay, so it gives in providing more clarity. Output technology issues. Output technology. So the output technology, I'll go very briefly over this and very quickly over this as well, because this is very common and I think most of you should be familiar with this. So there are certain types of output technology, okay, that your system should be able to work with. Okay, now if you look at the second point, okay, forms, reports and documents have to be created to be accessible from workstations, notebooks, tablets, smartphones and other devices. Now this is where the issue comes in. The issue comes in when you are designing a system. So the system design needs to cater for all the possible types of output technology. Nowadays, not only you have PCs, you have laptops, you have computer screens of different sizes, you have notebooks, you have smartphones, you have tablets and so forth. So a report that you're generating should be able to be compatible with almost any type of output technology. Okay, so there are other forms of output technology as well. You have emails, you have blogs. What are blogs? Blogs are web-based logs. That means we talk about blogs, that means people go around on the web posting some form of news or some form of events. Okay, you have instant messaging, IM, you're very much familiar with that, Viber, Messenger and so forth. And then you have wireless devices that are able to transmit data across the internet. So you have your mobile phones, okay, you have your tablets, you have your laptops and so forth. You have digital audio, images and video. You have podcasts. What are podcasts? Podcast is where, just like you have YouTube, you are able to view videos of others. Podcast is very much similar to YouTube, but no video, only audio. Okay, and automated fax or fax back systems. Now, fax systems has become obsolete. People don't use fax anymore. If an organization uses fax till date, I think they are very behind. Okay, because emails are more effective these days. All right, and then you have some specialized forms of output as well. Okay, you have a retail POS systems, point of sale. Okay, where this is where you go to the cashiers and they are able to cash in the item for you. So how does retail POS systems work? So first of all, data needs to be entered in the point of sale system through the use of a barcode. So a barcode represents a product. So then the particular barcode is printed out and pasted on the item. So generally when you would be going around in a supermarket, when you buy something, so it has a set of barcode. So that barcode is scanned off through a hand scanner or a desktop scanner at a supermarket counter. So if it matches with a barcode in their record, it will pick up the item. Just in case if it does not matches, so the cashier goes around entering it into the system manually and trying to figure out what is the price of that item. However, that's risky. Why is risky? Let's say you are buying something. Let's say you buy a Palmolive sanitizer. Okay, so Palmolive sanitizer. Let's say there are 10 different sizes. So you buy something worth, you buy a sanitizer which is 150 grams. And just in case, and just by mistake, the cashier selects 250 grams. So you'll end up paying more in that case. So that's risky. Whereby when you use a barcode, there's also likely a chance that sometimes errors could be done. Because remember, people who are entering this, they are, these are people who are entering all the barcode information with the system. They can make an error every now and then. So that's why when you're shopping, you always need to check the price of the item that you have cashed out against what you see on the counter in the shelves of the in the supermarket. Other forms of output technology is ATM. Now, why ATM is an output technology? Output's money. Okay, you feed in your information, that's input. Output that you get is receipt and money. Okay, you have special purpose printers. Special purpose printers are those that are used in printing firms. We have barcode printers as well. You have label printers as well. Okay, you have stamp printers as well. There are so many different types of printers. Okay, you have plotters. Plotters, they were used a bit back, okay, but they're not used much of it. I don't see people using plotters anymore. Plotters are used to create graphics. Okay, generally graphics which are used in architectural designs and engineering purposes. So those are machines, okay, which print those architectural designs. They don't use it anymore because nowadays we have way more specialized digital architectural printing machines. And then you have electronic detection of data embedded in credit cards, bank cards, and employee identification cards. Just like you have a just like you have your bank cards. Okay, so there's a chip inserted in the card. So when you put it into ATM machine, it reads data off the chip and then represents you with your account details. Asks for authentication first though. So when you enter your ATM card, it knows that it will say hello, your name, and then enter your PIN. So once you enter your PIN, then you get access to that account. Otherwise you don't. So input technology, okay, now you will need to know what is batch input or batch processing and online processing. Now batch processing is whereby the data entry work is done in a specified time schedule. For example, probably weekly or daily, okay, not instantly, weekly, daily, or monthly. Now opposite of batch is online data entry or online processing, is whereby you process the data as the event occurs. A very good example of online data entry is the ATM, or online processing is ATM. As soon as you withdraw money, you get the balance in the receipt. An example of batch processing is something like this. Let me think. I don't know how many of you pay car insurance, or if you have your parents who are paying car insurance, you pay the insurance and then they will tell you, okay, you should be able to get your letter within few days time, probably 7 to 14 days, and it will come in your postal box address. Okay, why? Because they do the main entry in Suva, but if you're paying in Lotoka, They will give the receipt, the source document is sent over to server, and then they will go around entering into the system. So that's an example of batch processing. Okay. So other types of input technology is point of sale. Now, how does point of sale becomes output and input technology both? Now, output, what does it output? It basically outputs the price of the product. Okay. Input is whereby the users go and actually enter the details of product into the system. Okay. ATM again is an output and input. Output gives out money. Input takes in the bank cards and takes in the information. For example, your PIN code from the user, the amount that you're after, it takes in from the user as well. So those are input. Okay. Factory employees use magnetic cards to clock on and off specific times. Yeah, I don't know if you have seen this somewhere or not. If you have been to FNU Namaka campus, in Namaka campus, it used to be there. It doesn't have it anymore. Biometric that was used for staffs. So first of all, we had the magnetic card thing whereby your ID card, you have to swipe it across that machine and then it picks in your time in and time out. And then we had the biometric, okay, whereby your thumbprint was taken in and so forth. Now, hospital imprint barcodes on patient identification bracelets. Now, we don't have patient identification bracelets here in Fiji, but I've seen people in overseas countries, they have it. It's just like if you are diabetic or if you are a person who is going through a severe illness, so they'll give you a bracelet, so you wear it just in case if you go through some unforeseen circumstances. For example, you faint off somewhere while you're walking alone or in the streets. So when somebody sees the bracelet, they know, okay, this person is diabetic, he or she needs urgent attention. Okay. And what happens is as soon as the person goes into the hospital, so that bracelet is been scanned off. Okay, it's scanned, it has a chip to it, so it scans off, it has a chip or it has a barcode to it, it is scanned, and the entire detail comes into the computer system. Technology, right? How good it is. I'm sure if we use it here in Fiji as well, it could be very effective too, but I'm not sure if people would be able to handle it in terms of financially, because those things are a bit expensive as well. To over here, we don't have that much of medical insurance facilities. Okay, if you're working for a good organization, you have medical insurance, so you go and see the doctor free of charge, just a little fee as much as $2 to $3 to $5, and medication will be free as well. But most of the families here in Fiji, we don't have medical insurance. So because of no medical insurance, there is a lot of reluctancy to go and visit the doctor because they're not able to pay in the fees of medication and treatment. Okay, so I don't know whether it will work here in Fiji or not, but it will be good if we see such kind of things over a few years of time. It will really help the people. Moreover, such things like this also may represent to people. Okay, just be careful with people who are all around. Be more caring towards them. Okay, and so forth. Now, retail stores use portable barcode scanners and libraries use handheld scanners. Yes, we do have them in the library. When in all FNU campuses, when you go and loan off a book from the library, they take in your student ID card, scan it off, and after scanning it, your record gets entered into the system. So what happens, it enhances productivity. How? So if there was no scanner, barcode scanner, so the attendant at the library will have to go and enter those details manually. May take a lot of time and effort, and sometimes there's a likely chance that errors may incur. So to avoid that, so there's a system whereby all the books have barcode readers. So the books will go through that barcode reader, and then your ID cards would be swiped off with a barcode reader as well, and the entire detail of the book and yours will be entered into the system, and you'll be provided with the due date. Now, security and control issues. As much as it is important to provide good level of input, good level of layout, and good level of designing the interface, you also need security as well. Now, this is very simple. Why do you need security and control? Is just to ensure that your data is protected from unauthorized access. Now, whom do you protect it from? You protect it from hackers, you protect it from viruses, and most importantly, you protect it from your employees as well, because one of the biggest threats of information for an organization is the employee itself. Okay, so you need to know what level of access to be given to an employee. Slide number 39. So input control is when you are entering data, what are some form of the controls that you need. So very first of all, some of the easiest way in which you can have input control is by using username and password. So when you're entering your username and password correctly, only then you have access to the system, else you don't. Another thing, sometimes you must have noticed, it's very common in supermarkets, if you make an error, or if you go around edifying or modifying something, you need a higher level of access. So you must have seen sometimes if there is something wrong while cashing out your item, so the cashier will call out something and a supervisor will come in, they will enter the username and password, and then they will actually go around modifying the price. Okay, you normally hear cashiers calling out markdown, something like that. Okay, modular design. So how it is designed, or how do you lay it out? Modular design is whereby you try to work in modules, different modules, and then you combine them together and form a bigger system. So let's say if your entire system has close to about 15 modules, so you work on module 1 first. Once that is fully working, then fully tested, fully working, everyone is satisfied, you pick up the lessons from there, and you pick up all the errors that you did, and then you work on the second one. So when you work on the second one, you know what things went wrong, what lessons you have learned, and according to the lessons learned, you design the second module effectively. That will make it a faster process, rather than you make the entire 15 thing all together at once, and then you have a lot of issues later on. Prototyping. Okay, prototyping is just like you are making a model of a system or a dummy of the system. So what does it do? Okay, it involves repetitive sequence of analysis, design, modeling, and testing. Why repetitive? Is just because this is the sample, and this is where you can play around with things. When I say play around, you can see, you know, generally when you have an actual system, you can't play around too much. Okay, it doesn't give you that flexibility to actually go and do whatever you want. Over here, you can try different versions and see which one best meets and suits the need. So prototyping provides a full-featured working model of the information system. Please ensure to know what prototyping is, and also know what are some of the benefits and limitations of prototyping. Some of the benefits of prototyping is that users and system developers can avoid misunderstandings. Like I've said, prototyping provides you with a platform to go and do a bit of trial and error. Okay, so with prototyping, all misunderstanding of if a developer thinks no, the user is incorrect, the user thinks no, the developer is not understanding me properly and doesn't want to provide this and that, and to avoid all that hustle and bustle. Okay, so a prototype can be done. That's where all misunderstandings could be easily cleared out. System developers can create accurate specifications for the finished system based on the prototype. So if once your prototype is there, fully fledged, working fine, all you have to do is you have to replicate that into the actual system. Managers can evaluate a working model more effectively than a paper-specific design. Now, you have a logical design. A logical design is something that is done on paper. Now, a prototype is an example of a physical design. Physical design is when you actually try to get the thing done, okay, in real life, not on paper. So when you're doing on real life, if it's a working model, what happens is the managers, the project managers, even the users can go around evaluating the entire system. It helps in developing testing and training procedures, reduces the risk and potential financial exposure that occur when the finished system fails to support business needs. Like I mentioned earlier, if you would create a design and then if you would create a system and then something goes wrong at the very end, or right when you have done, you feel, no, this is not what I wanted. I wanted this and that. So with a prototype, all those could be avoided, and it becomes easy to make changes before. And the final thing is, all you have to do is you have to redesign it into a working model. Now, problems. With prototyping, there's a rapid pace of development can create quality problems which may not be discovered until the finished system is operational. Now, with prototyping, sometimes it can be treated more of a task rather than of a quality. Why? Because it's just a pace of getting things done as soon as possible. So if that is the case, now it doesn't happen all the time, it can happen sometimes. If that is the case, then problems may be figured out later onwards. System requirements such as reliability and maintainability cannot be tested adequately using a prototype. True. Why it cannot be tested adequately is because, remember, prototype is just a version or just a dummy of a actual model. So you don't go around creating each and everything in detail. So once you actually start working on detail, that's the time you realize, okay, maybe it's not so reliable, or we couldn't test the reliability as effectively as we could have done with the working model than with the prototype. In complex systems, the prototype can become unwieldy and difficult to manage. Clients may want to adapt the prototype with few to no changes, leading to an increased maintenance cost later in the SDLC. Now, I have worked in one or two organizations previously, one specific organization previously, whereby we were working with projects. Now, with projects, you generally have clients. Now, what clients sometimes would want is something like this. When you go and get the prototype done, they will quickly have a look at things because they think, okay, this is not the actual thing. Okay, it's just a prototype, a dummy version. So yeah, it looks good. Everything is fine. But once the actual system is developed, then they start figuring out, no, this is not what I wanted. This is how I wanted things to be. Okay, so client factor may also be a problem when you deal with prototype. Okay. So summary, purpose of system design to create a physical model of the system that satisfies the design requirements that were defined during the systems analysis phase. User interface must be based on perspective of the user. That means it should be user centralized. Types of printed reports, you have detail, exception, and summary reports. Okay, and don't worry about the various zones. Okay, the method of input include capture data and data entry, and security and control plays an important role in designing. So what I want you to do is I want you to know what user interface is, what is HCI, and why it is important. Moreover, you should know the different types of reports that you have: detail, exception, and summary. You should know some input technology and output technology in user interface designing. Also know what is prototyping and the benefits and the limitations of prototyping. And that's all that I have for this week's lecture. Is there any questions or any queries from anyone? Any questions, any queries from anyone? No? Okay. If no questions or no queries, this is what I want you to do. Now, I was preparing your progress report. Your progress report is just like the department keeps track of each and every student's level of doing the assignment. Okay. And what is your mark towards the mid of the semester? Okay. So we have passed the mid of semester. We're into the second half of the semester. Now, if you are one of those, okay, now the total coursework that we have covered approximately in CIN603 so far is about 25%. 5% from your lecture-based quiz and 20% from your mid-semester exam. If you are one of those whose coursework mark is less than 12.5%, you are on the red zone. That means you are at a stage whereby you are failing the entire course. Hear me out also. If you're someone whose mark is between 12.5 to 15%, you're also in the red zone at the moment because you are just about 2.5% more to having a failed stage in passing CIN603. So please ensure that you start picking up your paces soon. There are a lot of you who have not yet attempted your lecture-based quiz from week 1 all the way down till week 6. If you are one of those, please do not load up. I've been reminding you since the very first week of the semester, don't load up things to the last moment. Most of you are doing 4 courses. Okay, if you are thinking that you will do all the quizzes somewhere towards the end of the semester, I'm sorry, but you will be causing a lot of issues for yourself come the end of the semester. Okay, so please ensure that you try and work hard and get a good grade. Now, I also know in CIN603, we have a good set of students who can score A+. Okay, almost all of you have the ability to do so. Some of you are new, but I have marked your mid-semester exams. I know your capabilities. Okay, so please work hard, try your very best to get an A or A+ in this course. Okay, and yeah, if you have problems in terms of submitting your assignments on time, or if you're one of those who have not yet attempted your mid-semester exams, drop me an email and I'll see what we can do. Okay, we can get a special exam done, something like that, provided first of all we have to revert this matter to the head of department, head of school first. Upon their approval, if they approve, then we can go around giving you special exams. I'm not promising anything, but drop me an email first and let's see what we can sort out. All right, everyone, any questions? No questions? Okay, just a final reminder, week 12 you have your short test. 31st October, that's where your is it 31st October? What is the date your project is due?
Same.
31st. Okay, 31st of October. Now this week on Friday, we will hop into the 1st of October. So a little more than a month left. Try your best, try to get your assessments done as soon as possible. The earlier you do it, the better it will be for you at a later time for your revision and so forth. All right, everyone, so this is all that I have for today. So thank you very much for putting in your time and efforts. I'll see you all on Thursday morning in your tutorial and lab class. Till then, take care, stay safe. With Naka.